So as we just said, these are the three types of compound probability, but this video is only about one of those. Independent sets. This is information where each thing is a separate event that can't really come together. So, for instance, let's talk about flipping a coin. So if I flip a coin, there are really only two options that I can have: heads or tails. It is either heads or it is tails. It cannot be both. So the odds of me getting heads is 1 out of 2, or 50%. The odds of me getting tails is also 1 out of 2, or 1/2, or 50%. So if I asked you what are the odds that I get heads or tails, we would add 1/2 and 1/2, or 50% and 50%, and 1/2, and that would be union. 1/2 plus 1/2 is 2/2, or 100%. Now, what if instead of flipping a coin once, we wanted to flip it twice? So, what are the odds that we would end up getting heads and heads? Well, we have to think of what all the possible combinations might be. So we could get heads and heads, but we could also get heads and tails. Or we could get tails and then heads, or of course we could get tails and tails. So you will notice that there are 4 distinct possibilities, meaning the odds of me getting heads and heads is one of the 4 possibilities, or 25%. Now, is there another way I could have done that? Well, you might remember from the last couple of slides that we mentioned that the odds of getting heads any one time was 1/2, or 50%. Well, if I multiply 1/2 by 1/2 instead of adding, you end up getting 1/4, and half of 50% is also 25%. So as you can see, we can just multiply instead of having to figure out the complete list of possible things, which is important because sometimes you have a longer list than you think. For instance, what's the probability that we flip heads, 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 tails, heads, tails? Well, each one of those has a probability of 1 out of 2. So we would do 1/2 times 1/2 times 1. You know what? It's 1/2 to the 6th power. And that gets us 1 out of 64, or approximately 1.6% odds that we would hit this exact thing. But now here's the thing. If we hit exactly this, what would the probability be that our next coin would end up being heads? It's 1/2, because we already hit those other ones. Each time you flip the coin, no matter how many times it says it hit heads already, it still is a 1/2. So if you discover heads, 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 and then someone says, hey, what are the odds it gets heads again? The odds are still 1 and 2, because those other things have already occurred. It doesn't change the odds this time. Alright, so now let's talk about a different form. We're now at a Coke machine, and we are wondering what is the probability that we get 2 types of Coke in a row if we are pressing random buttons on this machine after obviously paying. Because if you're not paying, the probability is 0, unless it's broken. Ooh, a broken machine giving me free Coke. Anyway, moving on. So, for us to know this, we actually need to know a couple of terms. And that is, we have to know, is it with replacement or, alternatively, without replacement. With replacement means that after I get a Coke, or I get a Coke Zero, or a Diet Coke, or any of these, there is another one that goes into its place. So if I keep pressing Coke, it will replace. On the other hand, without replacement means that once one of these is gone, they are gone. So, we're going to start off by talking about the probability that we get 2 types of Coke in a row with replacement. So, with replacement, to get in a Coke the first time, it would be 3 out of 8, because there are 3 types of Coke: Coke, Coke Zero, and Diet Coke. Now, after I've gotten my first one, I then try to get another Coke, and then the odds are still going to be 3 out of 8 because all 3 types of Coke are still there. So 3/8 times 3/8 ends up getting us 9 out of 64. Now, what happens though if suddenly there's only one of each beverage left in this vending machine? Well, our first time is still 3 out of 8 because there are 8 different drinks. But then the next time we have one less drink. So if we got a Coke the first time, there's now only 2 Cokes left and there's only 7 drinks. So we do 3/8 times 2/7. 3 times 2 is 6. 8 times 7 is 56, meaning the odds are now 6 out of 56 that we are able to get a Coke 2 times in a row. And that's it. That is independent sets. All right, please watch the next video where we talk about dependent sets. Exciting.